Good morning and good afternoon. Good morning to Core 1, 2, and 3 Stingrays and Core 4 Stingrays. Good afternoon. I'm sorry I cannot be with you today, but I will see you tomorrow Thursday, so make sure you're on your best behavior and make sure that you work your very best. As far as last night's homework, if you have any questions, please do not bother to substitute. I will cover those questions tomorrow. Today what we're going to do is we're going to review one-step equations. We will be working on adding, subtracting, multiplying, and dividing fractions and decimals in these equations and inequalities. We'll be breaking these problems down and solving them. And the last thing I'm going to add, just add a little twist. On a separate piece of paper, I would like for each of you to graph the inequality and equations. Oh, that's boring. These are all equations. Boys and girls, pull out your worksheet, or I should say flip over your worksheet to the side that has the rocket ship on it. We're going to start with number 2. As stated earlier in my intro, I am sorry that all of these problems are equations. Equations are very boring to graph. They're just going to be a dot on a number line. We might spice it up later. But as far as solving equations and inequalities, they're pretty much the same thing. You have to treat it like a balance beam. What you do to one side of the equation, you must do to the other. The whole idea, the whole purpose and goal is to isolate the variable. What does that mean? You want the variable on one side of the equation with all the number information and junk on the other side. Once you've accomplished that, you've solved the problem, you know what the variable is, and you're done. Okay, let's start out. We first always look to see, is there anything that we can simplify? And I believe all these problems that you have for examples today are already simplified. There are no like terms that you can combine on either side of the equation. So then the second step is begin the isolation of the variable. So in order to isolate the variable, we need to ask what's happening to the variable. Well, I have variable x over here, and 5 and 96/100 is being added to it. Well, I want to do the inverse of that, which is the opposite. So I want to subtract 5 and 96/100 from that side of the equation, and whatever I do to the left-hand side, I must also do to the right. So I subtract 5 and 96/100 from that side. When I do that, this cancels that out. I will bring down my variable. I will also bring down my equal sign, and then I will do my operation, my inverse operation. I cannot take 6 from 3, so 3 has to borrow from its neighbor, and 3 becomes a 13. 13 minus 6 is 7. Don't forget to put your decimal point there. 0 minus 9, I cannot do that, so I must borrow from the 8. The 8 becomes a 7. The 0 becomes a 10. 10 minus 9 is 1. And then 7 minus 5 is 2. So the variable x is equal to 2 and 17/100. And if we were to graph that, look at how exciting this would be. We could say this is 2 on the number line, and this is 3. I know that 2.17 is somewhere on the number line, and more than likely it is closer to the 2, and then I would put a dot right there. Exciting! Exciting. Okay, and that's how we'd graph it. Let's not graph anymore, it's just too much excitement. Number 6. Now we can see that we are not adding a fraction or a decimal, but this time we are subtracting. No need to simplify. There's no like terms that we can combine on either side of the equation. So we're going to isolate the variable x. We have to ask ourselves what's happening to x. 6 and 47/100 is being subtracted from it. Therefore, we must do the inverse operation. The inverse operation is add 6 and 47/100. What we do to one side, we must do to the other side. So we add 6 and 47/100 to both sides. If we have a negative 6.47 and a positive 6.47, they cancel each other out. I bring down my variable x. I bring down my equal sign. X is going to be equal to the sum of 2 and 7/10 plus 6 and 4700ths. I'm just going to put a 0 here as a placeholder. 0 and 7 is 7. 7 and 4 is 11. Put my decimal point there. Carry my 1. 1 and 2 is 3. And 3 plus 6 is 9. So my answer is 9.17, or I should say, x is equal to 9 and 1700ths. Let's take a look at the next one. Let's take a look at number 5. Now this time we are not adding a decimal, we are adding a fraction, which makes it a little more spicy. We know that when we add or subtract fractions, which we're going to have to do in order to manipulate this equation, we need to have denominators that are the same. And we can clearly see here that 2 and 5 are not the same denominator, therefore we need to find the least common multiple of 2 and 5. And most of us probably have it off the top of our head. But if we started listing, we'd list 2, 4, 6, and eventually, we'd get to 10. On the other hand, over here, we just start skip counting. We'd have 5, 10. So our LCM is going to be 10, and we need to find equivalent fractions for 1/2 and 6/5 that both have the denominator of 10. And an equivalent fraction for 1/2, well, we know what do I have to do to get this 2 to kick it up to a 10 would be multiplied by 5, and whatever I do to the top, I must do to the bottom. Over here, what do I have to do to the 5 to kick it up to a 10 would be multiplied by 2, and whatever I do to the numerator, I must do to the denominator. So we're going to end up with 5/10 over here plus x is equal to 12/10 over here. All we did was find equivalent fractions for 1/2 and 6/5 with a common denominator. Now we can get to work. Well, if I'm adding 5/10 to x, what's the inverse or opposite of that? We need to subtract. Once again, there's no need to simplify. We've already done that. And what we do to one side of the equation, we should do to the other. So there we have it. 5/10 minus 5/10. These bad boys will cancel each other out. I bring down my variable and I get an x. I bring down my equal sign. And now I have 12/10, and if I take 5/10 away from 12/10, that will leave me with 7/10. And there is my answer. Okay, and let's just, for kicks and giggles, let's say this was an inequality, and our answer was x is less than or equal to 7/10. What would that look like? I've got my number line over here, and I know that 7/10 is somewhere between 0 and 1, or at least I should know that. Okay, and 7/10, if I were to break this into 10 increments, 7/10 would probably be right around here. And what I would then do is I would put a circle around 7/10, and you need to ask yourself, would I leave it empty or would I fill it in? The answer is I'd fill it in, because x can be equal to 7/10, so I'd fill it in. But x can also be less than. So then I would have a ray pointing here to the left saying that it can be anything less than 7/10, including all of the negative numbers. But once again, this was just for fun over here. The answer to the problem, to our equation, was x is equal to 7/10. Boys and girls, let's put down our pencils for a moment. Just pay attention. Here is an example I'd like for you to take a look at. Since on your worksheet we don't have any examples of subtracting a fraction from the variable in our equations, and we don't have an inequality, I figured I'd make one. So here we have it. We've got x minus 5/6 is greater than or equal to 6/5, and we need to isolate the variable since we cannot simplify. We need to ask ourselves what's happening to x.
It's 7 o'clock.
We're taking away 5/6. What's the inverse of that? Adding 5 over 6. And what I do to one side of the equation, I will do to the other. And I hope you're all writing this down. Well, no, you don't have to write this one down, but the others you should be writing down. We know that if we have a negative and a positive 5 over 6, they cancel each other out. So I have nothing but the x left. I finally isolated it. I bring down my inequality sign, which is greater than or equal to. And, oh, look at this. I have 6 over 5, and I'm trying to add 5/6 to it. Well, let's see if I can come up with an equivalent. I should have done this to begin with, but it's not too late. I can go off here to the side and say, okay, what is a common denominator between 5 and 6? And the LCM is going to be 30. Okay, so I need to ask myself, what do I have to do to 5 to get it to be 6? I'll multiply it by 6. And when I do the top, I must do the bottom. And then over here for this guy, what must I multiply 6 by to get 30? I must multiply it by 5, and when I do the top, I do the bottom. See, what I'm really doing is I'm multiplying it by 6 over 6, which is 1. That doesn't change the value of it. And I'm doing the same thing over here. I'm multiplying this by 5 over 5, which is really 1, which doesn't change the value of the fraction. But I do end up getting 36/30ths for my original fraction, and I get 25/30ths for the fraction that I'm adding. When I add these two together, 36 and 25, let me see, 6 and 5 is 1. Okay, carry the 1. Well, actually it's 11, so carry the 1. And then I have 1 and 3, which is 4 plus 2 is 60. So I have 61 over 30, which then I can reduce this. 30 goes into 61 2 times, and I'll have 1/30th left over. So I can say that x is greater than or equal to 2 and 1/30th. And let me just slide this up for a second here so you guys can see what's going on. Okay, and I'll go back to that. And let's change the color to blue. I've got a blue number line here. And I know that 2 and 1/3 must be somewhere between 2 and 3. And this isn't 1/3, this is 1/30th. So, gee whiz, this is going to be super close. Okay, 2 and 1/30th is going to be super close. Let's try a different color. Let's use green. I circle it. Do I fill it in? Yes, I do, because x can be equal to 2 and 1/30th, and it can also be greater, which means it can be anything to the right of 2 and 1/30th. And there you have it. Our answer, though, is x is greater than or equal to 2 and 1/30th.